Okay, so solving equations, we're going to do some warm-ups about talking about operations and what are their opposite operations. Okay, so for instance, addition is one operation. What's the opposite thing of adding something? Subtracting. So what's the opposite of subtracting? Adding. See, it goes both ways, right? What's the opposite of dividing? Multiply. What's the opposite of multiply? Dividing. So this is called squaring something. So some kind of number squared. So the opposite is square root. Okay, so the opposite of square rooting is squaring. Okay, so with equation solving, our goal is to always end up with a letter, a variable, alone. Okay? I mean, a lot of the times in math, we use x, but that's not always the case. It just is a letter. Okay, so the goal in equation solving is to always have this letter alone. So what I see when I look at this expression, if I wanted x alone, how do I get rid of the other stuff? So I would have to add 5. Okay, I'm trying to get rid of it so I can have x all alone. That's the goal. So x right now is being added with a 12. So to get it alone, I would subtract 12. Right now, there's a subtracting 7, so I would add 7. If there's an add 9 with it, I would subtract 9. What would you do here to get x all by itself? Subtract away the 8 that's there. What is connecting these together when they're side by side glued? It's like a secret code, right? They're multiplied right now, so I would have to divide by 7. Okay, here, same thing. They're glued side by side, so this is, again, a secret, multiply. It doesn't have a symbol or anything if they're together like that, so I'm going to divide. X is being divided by 3, so I will times by 3. If you guys are okay, a lot of the times I might use a dot for timesing, just because it's, if you have an X and then a times symbol, that might be confusing. X divided by 15, so I'm going to times so here x is square rooted, so I'm going to square it. Here x is being squared, so I'm going to square root it. Okay, so that's the gist of it. Always you're going to think opposite. You're trying to get rid of stuff to get that letter alone. Okay, so here we go. These are the simple one-steppers. So to get x alone, I need this gone. So how would I do that? Subtract 7. Okay? Do you understand that math equations are like teeter-totters? If you took 7 people off of one side of your big teeter-totter, what do you have to do on the other side to bounce it back off? Take 7 off the other side. Okay? Here's what always happens when you're doing this work properly. The goal is to cause something to disappear. because 7 subtract 7 is 0. That's disappearing. So now that was the goal. Get x alone. X equals 12. Okay? Every time you solve an equation in math, you always have the ability to go back in, plug it in. So if I wanted to check, I could go 7 plus 12. Does that equal 19? Would that work?
Yeah.
Yeah. Okay, number 2. I want y, so different letter. I want y all alone. So this is the thing I need to attack. Need to get that out. So I would have to do a +2 to get it out of there. Always an opposite thing to remove something. So what am I going to also do on the teeter-totter? Add 2. So that causes a disappearance. And I get a y. And then be careful with integers. Can you tell me, is that going to be a -12 or a -8?
-8.
That's going to be a -8. So that's an integer thing that you should know from grade 8. Okay, how do I get x alone? I need to get rid of that. So right now what's happening? They're timesing, so I need to divide by 2, but I need to teeter-totter it. Okay, like I said, there's always something that gets that canceled process. Gone. Okay, number 4. I would like to attack that. I need it gone. So it's divide by 7 right now. So I'm going to times by 7. So this 7 timeser and 7 divider cancel. Okay, and the last one. I need to get rid of the square root symbol on the x. So I should square it, which means I also have to square that side. Okay? This is the stuff that would disappear, square rooting a square. X equals 81. Okay. So when you evaluate something, okay, when you evaluate something, so the word evaluate means figure out a number. Okay, what would I do when I evaluate this? Multiply first, so 8, and then I would add. Okay, so the word evaluate means that, figure out the number. So I used BEDMAS. Okay, now this unit, we're talking about equation solving. So when I equation solve, I work completely opposite of evaluating. So what's the opposite of bed mass? Can you write that backwards? Sam, Deb. So that means what? Okay, so it tells me now I actually have to do add subtract first. So here I would -5, which is 8. So I added, subtracted first. Then I would do some multiplying and dividing, which tells me to do what to get x? Divide by 4. X equals 2. Hey, look at what we started with right there. We started with a 2. Okay, so evaluating is bed mass. Sam Deb is the opposite of that. And that's what you use when you do equation solving. Okay, so here's an example. Very similar to the one I did. 6 times 2. So you'd have to do this first to be 12. Then 12 plus 9 is 21. Okay? Then you can see my work here with equation solving. If I wanted to get this multiplier here, I had to actually do the add subtract first and then the divide. Okay, ready? So now we're going to do some two-step equations. Here we go. Okay, which one should I attack first? Divide by 3 or subtract 1? You have to attack the subtract 1 first, okay? You cannot attack this one because do you remember what connects a term together?
Bracket.
What makes a term? Multiplication or division? Okay. So do you remember from last unit? That's glued together right now. So I can't unglue it until the end. Okay, so the first step was add 1. Sam Deb, add subtract first. So that's what I look like. Now I need to do what opposite process now?
Times by 3.
Times by 3. Times by 3. Okay, what can you always do at the end? What's the thing you can always do at an end?
You can always square or circle the answer.
No? Well, I'm going to do that, but what should I always do in a test at the end of a question?
Check your answer.
Check your answer. How would I check that?
By reversing it. By going.
Plugging this, yeah, we're plugging that in. Okay, ready? In your heads. If I put a 21 here, what's 21 divided by 3? 7. What's 7? Subtract 1. 6. Okay. Step 1. What should I do? -1, good. That's the first attack. Okay, the square root of b now. Remember the goal is I want b all alone with nothing else with it. So then the opposite thing would be to square it. Okay. I'm going to make them harder now. This one gets harder. Actually, no, the next one gets harder. What's your first step? Minus 10 away. Okay? That's the thing that disappears. Okay? I got to stop you here. There's a little bit of too much noise. I'm starting to really hurt talking over you. Okay, 10 minus 10, right? That's the part that goes. So, negative 2y, did you copy that down? The negative? You don't have your calculators. What's this integer math? If you go down 20 and then down 10 more. Negative 30. Okay, what's happening with the y? Multiply, so I divide. And you should also remember 2 negatives make a positive. Okay, I need you to star this one. Yeah. That is, but I need you to understand the process of getting there. Okay. So, why did I put a star beside this? You cannot solve for a variable on a bottom. Okay, Coco, can I just get you to move to this blank table over here, please? Just the one that's empty by yourself. Thank you. Okay. You can't solve for a variable on the bottom. Can't. Okay. So, does anybody have any thoughts about how to get rid of it being on the bottom, that problem?
Or you switch around the 4 and the C.
Okay. That's good. But, so, switching the 4 and the C, that's good. What was he actually doing in that process? Annika, were you going to answer something? Because I think it was right. Times by C. How do you get rid of a divide by C? Times by C. Okay, so you cannot do a variable on the bottom. So if I get rid of the divide by C, that's going to be a times by C. Okay, so there's what I'm at. Timesing by C, got rid of that. Timesing by C.
Then do you just reverse it and go 4C divided by?
And now, how do I get C alone?
Yeah, 4C divided by.
If it equals, then you can switch it.
Divide by 4. So there's where you said switch them. They end up doing that. Okay, this is good to write. This is the same thing. C equals 6, 6 equals C. All good. Doesn't matter the order that you write it in. Is this like then, is there in your booklet like lots of pages in between where I'm?
Yeah, this goes to that.
Is this part of it? Or is it's still going? Okay. Let's talk about these ones. Now I'm getting really tough on you. Okay. Paying attention. This is harder leveled. Okay. Remember this. This is glued together right now because it's one term. This is separated from that. Do you see that? Okay. Also, when you see something like this as a fraction, it's implied that this is in brackets. Can you do that? Can you give me brackets on there? That's an understanding, so you have to know that in math. So this is one term glued. This is out of that term, okay? And then this is an implied bracket. Okay, what do you want to get rid of first? So we could do some dividing by 2, a minus 1, a times by 3, and add 3. Which one has to come first?
So add 3.
That separate thing has to go. So what did you say? We're going to
Add 3.
add 3. Okay. Now, I'll give you some multiple choices. Here's your 3 options. Should you divide by 2? Should you subtract by 1? Or times by 3? Okay, the answer to that is multiply by 3 has to be next. Okay? So, are you wondering, well, she told me I had to do add, subtract before multiply, divide. I told you that, right? So why didn't I do the subtract 1? Because it's in a bracket. Okay? It can't be separated with its bracket stuff. It's like it's family. When you're in a bracket, you're a family. You can't separate yet. Okay, so now 2y plus 1 equals 15. So now I can do the separating of the family here, now that I did that. So minus 1 and divide by 2. Okay. Here we go. I'm going to do a quick check. Did we get it right? 2 times 7, 14 plus 1, 15 divided by 3 is 5. 5 subtract 3, 2. Okay, same thing. You know what I'm going to do? I'm going to put brackets around that. Hey, what am I doing? This is the same question. Never mind. Okay. Oh, I see what I did. I wanted to do my work over there. Okay. So what is our first step on this question? Step 1. So you have to add 1, add 1. So this is glued. That's glued together right now. So we're going to get rid of that. Okay, what are we thinking now? We got 2 more things to do. Okay, I'm going to give you options here. There's going to have to be these 2 things that happen. There's going to have to be a times by 3
You always times by 3.
and divide by 2.
You always times by 3 because the variable, the number with the variable, you always want last.
Okay. How many people think I should do this one first? How many people think I should do this one first? How many people didn't vote? How many people, again, think I should do this one first? How many people think I should do this first? Guess what? You're all right. It doesn't matter. In BEDMAS or SAMDEB, would it matter if I times or divided first? No. Okay. Doesn't matter. I'm going to pick this one. So I'm going to times by 3. So 2x equals 12. Then I'm going to divide by 2. Okay? Did anybody go the other way? Okay, so if I did it, here's what I would do. If I divided by 2, then the 2 timeser would be gone. Do you see that? If I divide this by 2, now that 2 is not there. Then if I times this by 3, look at what happens. Aha! So you were all right. Everybody who raised their hand on any of those options, didn't matter. If you didn't vote, you were wrong. So it sucks to be you. Because everybody else is right.